Now suppose a point P is taken which is at a distance r from the lower end. When it is slipping like this, you take a point P which is at a distance r from the lower end. This is center of mass. This will be L by 2. This will be, suppose if this angle is theta, this will be L by 2 cos theta. Because this is taken as distance r, this distance will be r cos theta. This distance will be r cos theta. This will be L by 2 cos theta. So, for this point which is at a distance r from the bottom, if you take coordinates x comma y, here understand the problem clearly. The rod is slipping like this. When it is like this, it is slipping like this to fall on the ground. While slipping, center of mass motion is along the same straight line downwards. It falls in this line only, but different points on the rod execute different types of motions. Here we are trying to find what kind of motion is executed by a point P which is at a distance r from the bottom of the rod. We are trying to find what kind of motion is executed by a point P which is at a distance r from the bottom. For that, let the coordinates of P be x comma y. Let the coordinates of P be x comma y. Then x means this distance. X is equal to, x coordinate of P is this distance, which is equal to this minus this. That means L by 2 cos theta minus r cos theta. That is equal to L by 2 minus r cos theta. Similarly, y means this distance. Y is equal to r sin theta. So, x and y coordinates we got. We can easily tell what kind of motion is executed by the point P on the rod. Now, x square is equal to L by 2 minus r whole square into cos square theta, or cos square theta is equal to x square by L by 2 minus r whole square. Similarly, y equal to r sin theta means sin r square sin square theta is equal to, let's write like this, r square sin square theta is equal to y square. So, sin square theta is equal to y square by r square. Now, add these two. Cos square theta plus sin square theta is equal to x square by L by 2 minus r whole square plus y square by r square. So, cos square theta plus sin square theta is 1 equal to x square by L by 2 minus r whole square plus y square by r square. That means this is the equation of an ellipse. That means this point moves in an elliptical path, which we don't actually guess without doing. You cannot have a even wild guess that it will move in an elliptical path, but that is the truth. If you try to find its motion, what we got is an equation in the form of an ellipse. So, the path of P is elliptical. Path of P is elliptical. Now, let us go for another point here. Let us discuss about the center of mass frame. What is this center of mass frame and how to simplify problems in center of mass frame. Center of mass frame means the observer is moving along with the center of mass, or all other particles are taken with reference to the center of mass. With reference to the center of mass. So, suppose there are two particles m1 comma m2. Two particles m1 comma m2 are moving like this, or they may be moving in the same direction also. There is no restriction that they are moving in the same direction or in opposite direction. Let its velocity be u1, its velocity be u2. Velocity of center of mass is equal to m1 u1 plus m2 u2 by m1 plus m2. You already know this formula. Now, m1 plus m2 into VCM is equal to m1 u1 plus m2 u2. That means momentum of center of mass is equal to sum of the moment of all the particles. So, sum of the moment of all the particles with respect to center of mass means how much? Generally, suppose a particle has momentum, like a linear momentum p1, another particle has a linear momentum p2, then what is the linear momentum of first particle with respect to second particle means p1 minus p2. Linear momentum of first particle with respect to the second particle means p1 minus p2. Similarly here, what is the linear momentum of the system of particles with respect to center of mass means this minus this, but these two are equal. Therefore, with respect to center of mass, linear momentum of system of particles with respect to center of mass is 0. This is a very important point. Linear momentum of system of particles with respect to center of mass is always 0. Why? Because of this. Linear momentum of the system with respect to the center of mass is 0, because that is nothing but this minus this equal to 0. Now, automatically velocity of center of mass, which is given by this, with respect to, suppose if you want, if you take linear sum of the linear momentum of the first two particles m1 u1 plus m2 u2, this is the sum of the linear momentum of the two particles. With respect to center of mass, this must be equal to 0. In the center of mass reference frame, total momentum of the two particles is equal to 0. That means P1 is equal to minus P2. P1 is equal to minus P2. After collision, suppose if they collide, after collision, then P1 dash plus P2 dash must also be equal to 0 in the center of mass reference frame. By the same logic, P1 dash plus P2 dash is also 0. P1 dash means final momentum of the first particle, P2 dash is final momentum of the second particle. So, P1 dash plus P2 dash is equal to 0, or P1 dash is equal to minus P2 dash. So, what we are getting here is their momentas are equal and opposite in center of mass reference frame before collision or after collision. This is one of the points. If two particles are traveling in any direction, in the same direction or in opposite directions, what we observe here is total linear momentum is 0 in the CM frame. In the CM frame only these results are valid. Remember that. In the center of mass frame, momentums of the two particles are equal and opposite. Now, let us proceed further from here. Now, if you try to guess what happens if the collision is elastic? If the collision is elastic, what is the total initial kinetic energy? Half m1 u1 square plus half m2 u2 square. What is the final kinetic energy? Half m1 v1 square plus half m2 v2 square. So, half m1 u1 square plus half m2 u2 square is initial kinetic energy. Final kinetic energy is this. But we are given that if the collision is elastic, then these two must be equal. These two kinetic energies must be equal. Now, if you write this as P1 square by 2m1 plus this as P2 square by 2m2, this is equal to P1 dash square by 2m1 plus P2 dash square by 2m2. Because kinetic energy is nothing but P square by 2m, there is a relation in work power energy. Ke of a body is always equal to P square by 2m. Ke of any body is equal to its momentum square by twice its mass. So, if you take the first particle, its kinetic energy is half m1 u1 square. So, its Ke must be equal to P1 square by 2m1. Similarly, P2 square by 2m2. Similarly, you write this. But if you see, P1 is equal to minus P2 in the center of mass reference frame. If you come back to center of mass reference frame, P1 is equal to minus P2, P1 dash is equal to minus P2 dash. Therefore, substitute P1 is equal to minus P2 here. Take squares both sides. Then P1 square equal to P2 square. So, you can write P1 square in place of P2 square. If you write P1 square in place of P2 square, this equation becomes like this. This is equal to you will get like this, because here also P2 dash square is equal to P1 square. Therefore, P1 dash square. Therefore, here also P2 dash square is equal to P1 dash square. You substitute, take out P1 dash square common, then what you will get is like this. Here also it is like this. Then if you cancel these two, P1 modulus of P1 must be equal to modulus of P1 dash. That means the initial and final momenta of the first particle is same. It may be in opposite direction. Naturally, it will be, because collision is there, no, it should be opposite. So, momentums, there is no change in magnitude of momentum of the first particle. Only change that took place in collision is direction. In which frame? In the center of mass frame. In the center of mass frame. So, this is the conclusion. When two bodies undergo elastic collision, in the center of mass frame, the particles linear momenta magnitude will not change. You can also show that P2 is equal to P2 dash. Because these two are equal, you can easily show that P2 dash, P2 mod of P2 is equal to mod of P2 dash. So, from these two results, what we can say is, after the elastic collision between two particles, only the direction of velocities will change, magnitude of velocities will be same. That means the speeds will not change during an elastic collision if the reference frame is center of mass. If the reference frame is center of mass, because M1 is nothing but P1 is nothing but M1 U1, P1 dash is nothing but M1 V1. So, M1 gets cancelled, V1 is equal to U1, mod of U1 equal to mod of V1. That means initial and final speeds of first particle are same. Similarly, you can show that initial and final speeds of second particle are also same. That means U2 is equal to V2. So, this is an important result. This U1 equal to V1 or U2 equal to U2 equal to V2 are with respect to which reference frame? Not with respect to earth reference frame or lab reference frame, it is with respect to the center of mass reference frame. With respect to the center of mass reference frame, we are able to show that in an elastic collision, simply the speeds, magnitude of velocities remain same, only direction of velocities change, magnitudes of momenta of particles remain same, only directions change. Speeds of the particles will not change after or before the collision, they will be remaining same.